me give you a riddle to guess. It never changes, yet it flows. What is it? If you have guessed that it is the time, you are right. It is a thing which are people trying to understand from the beginnings of the ages. This has been all sparkled by the ability of the time to affect us on daily basis. We are getting older, our nails are growing, flowers bloom, and the seasons are changing. Among a lot of conceptions which have been created by philosophers and scientists in order to understand this phenomena, there are some worth of the attention for their uniqueness. One of those is the conceptions of the time and its relationship to the universe, the block time theory. To be able to understand this phenomena, I will try to explain this to you in a way that may help you to understand this better. My name is Marketa, and I am here to bring you up to date with some interesting facts. Let's get started. So, to start this up, let me try to explain to you how does the theory work like. Have you ever read The Little Prince? If you have, you may be familiar with how did the author draw a sheep in a box. Inside of this box is that kind of a sheep we would want to own. Now, let's say the sheep is actually a universe. This universe is in the box, which means that in this box is everything that the universe consists of, which of course includes the time. Because the time is happening inside of the universe, it also has to end in the universe, as the time which is known in our dimension is unknown to the other one, which automatically includes the past and the future inside of the same box. This brings us to the conclusion that this box contains everything that has ever happened or will happen in the universe. So far, it shall make some sense. Now, if we know this, it may sound almost natural that all the events that have happened in the box universe are the cause of the events which are about to happen. Just as every action has its inevitable consequence, but in this case it is more advanced. Imagine that once in the universe's history used to live a dinosaur Larry. Larry was a T-Rex. Now, imagine you have a Pomeranian named Snowball. Snowball is a consequence of Terry's existence. This can also work in reverse. How is this possible? It is all caused by the fact that in the block time theory, we don't operate with terms just as past or future. Before you start to question this any further, let me hit you with a very simple explanation. When you woke up yesterday, you did not wake up into the past, but into the present. In fact, I am currently writing material to this podcast in the past, just to have you to listen to me right now in the present. You can see, the past has been the present, just as the future will be the present as well. In short, there is no past nor future in the block time theory, as the time itself is relative. This can also be applied to the present, as my now is different from your now. Thinking about Larry and Snowball again, we might get into the conclusion that if the time we know is a line on which we can mark up a point, which is the exact point where Snowball does exist, and then do the same thing to mark up the exact point when Larry was alive, keeping in mind that Larry is a prehistoric creature, you may be able to see that the fact that these two events are influencing themselves with the simple fact that they do exist. More precisely, If we stand in the middle of these 2 points and say that snowball is just about to exist in the future, we may get to see that the thing which we may call past is picking up an event that has to happen before the place we stand at now, just as the future picks up an event that is just as about to happen after the period we may call now. So, you may have noticed that the time is relative and there is nothing like past, present, nor future, as everything is present in some point of our lives. We may also say that if a person was to travel a couple of billions of light years away from the Earth and had a very strong telescope, he might be able to see dinosaurs roaming around the world, or if he went a little bit closer to the Earth, the subject might see the answer to the biggest historical mysteries, like, for example, the identity of William Shakespeare. This may mean that the now the person is witnessing is actually past, which does ultimately strengthen the theory that the time is relative. But this would also mean that we might be able to travel in time. Isn't that correct? About this has written Professor Christy Miller, who is a director of the Time Institute on the University of Sydney. When she was talking about the possibility of time traveling, she has answered the question like this. Remember, on the block time universe, the past is no different from the future or the present. Everything is relative. What is past to you will be the future to someone else. So, if I went back to the past, I am traveling to what is someone else's future. That means that the past won't be any different in kind to the present. What will happen if I travel to the past? I will get out of my time machine and start walking around. I will breathe the air and chat to people. Obviously, this will have effects on the time I travel to. I will tread on ants. I will talk to people from the time. I will pet horses and feed donkeys and so on. I will act in the past in the sorts of ways I act in the present. But I won't be changing the past. Just as when I eat cornflakes instead of a toast tomorrow, I am not changing the future. I am just making the future the way it is. When I travel to the past, I won't change it. I just make it the way it is and always has been. This means that if we travel into the past, we travel into someone else's future, and the present and the past are on the same line for every single one of us, just as the future. Changing the past might be a change for someone else in the future, but we are enough to do this, as this would be an inevitable cause of a contradiction, and there are no contradictions. But how are we supposed to travel into the past? Professor Miller has brought us an obvious answer: the black holes. We will talk about these a little later. But what exactly is the time in our world? Scientists have made a theory according to which the time is a separate dimension. This is supposed to be the fourth dimension. But what exactly does this mean? Let me give you an example. Why is the time a separate dimension? To understand how the events happen, we need to know about the space and the time in which they happen. When you are about to lay into the bed, it all happens at one point in the space-time, at the exact time not sooner nor later. As Evan Siegel has said in his article for Forbes, in order to completely describe an event in space-time, you need to know more than just where it occurs, but also when it occurs. In addition to X, U, and Z, you also need a time coordinate, T. Although this might seem obvious, it didn't play a large role in physics until the development of Einstein's relativity, when physicists started thinking about the issue of simultaneity. Funnily enough, it was not Einstein who has thought of this issue in his theory of relativity. It was his teacher, Hermann Minkowski. Siegel has described an event when Minkowski explained the unity of space and time in this way. Less than 3 years after Einstein's first introduction of his special theory of relativity, Minkowski demonstrated their unity with a brilliant line of reasoning. If you wish to move through space, you cannot do it instantaneously. You have to move from where you are right now to another spatial location, where you will only arrive at some point in the future. If you are here now, you cannot be elsewhere at the same moment. You can only get there later. Moving through space requires you to move through time too. Minkowski has also made one very important discovery when it comes to the space-time. He has realized that moving through the time is just the same as moving through the space, but with some additional steps. These are two factors. One of them is being c, which equals speed of light in vacuum, and then an imaginary number I. And thus, after completing the derivation of space-time for the first time, Minkowski has stated, henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. And for us, what does this mean? The previously mentioned line on which all the events are happening is now lying in a separate place in a box. No, I hope it makes more sense. Hence, it is in a separate place in the box, it's easier to travel in it. But just as mentioned before, to travel in these, we need black holes. We have been talking about black holes as the ultimate traveling means in the time-space. But what is a black hole? Everything happens to be created. How are created the black holes? As for this, we have to look at the stars and how they are born. On the beginning, we have the stardust. This foggy substance is the place where the stars are born. The elements are slowly connected to each other, creating a huge mass. This mass has a lot of energy going inside of it. On the beginning, the stars aren't small nor big. As the life passes, the stars get heavier and bigger. The space around them gets bent, and they start to drown in this hole that has been created by this immense mass. At this stage, the star gets the name red giant, which is quite fitting to their appearance. As they are drowning, the pressure and the energy that is accumulating inside of it reacts and create a very shiny star that eventually blasts. These blasts and the stars are called supernovas. When a supernova blasts, the energy from its blast alongside with all the elements and particles are able to create a cloud from which can a new star be born, but also a black hole. As you can see, the end really means a new beginning in this case. To make this more interesting, supernova can also create a neutron star from which will later on evolve a pulsar, which is a pulsating star that emits periodic pulses of radiation. But what is inside of black holes? According to Encyclopedia Britannica, details of the structure of a black hole are calculated from Albert Einstein's general theory of relativity. The singularity constitutes the center of a black hole and is hidden by the object's surface, the event horizon. Inside the event horizon, the velocity that's required for matter to escape from gravitational field of a cosmic object exceeds to the speed of light, so that not even rays of light can escape into space. The radius of the event horizon is called Schwarzschild radius, after the German astronomer Karl Schwarzschild, who in 1916 predicted the existence of collapsed stellar bodies that emit no radiation. The size of the Schwarzschild radius is proportional to the mass of the collapsing star. For a black hole with a mass 10 times as great as the Sun, the radius will be 30 kilometers. The biggest black hole, Ton 618, for example, is so big that it could devour the Milky Way. But don't worry, the supermassive black hole is way too far away to be a real danger to us. What is very interesting is that black hole has been found because it has formed into a quasar, a pulsating object that is brighter than stars. In fact, a quasar can be seen at a distance of billions of light years. This phenomena can happen as there is a lot of dust accumulating inside of black holes that can possibly come from galaxies it has devoured. Back to the time traveling through the black holes. Because black holes are actually stretching the space around them, they are stretching the time as well. When space is stretched, so it's time. A clock that is near a massive object will tick slower than one that is near a much less massive object. A clock near a black hole will tick very slowly compared to the one on Earth. 1 year near a black hole could mean 80 years on Earth, as you may have seen illustrated in the movie Interstellar. In this way, black holes can be used to travel to the future. If you want to jump into the future of Earth, simply fly near a black hole and then return to Earth. If you get close enough to the center of the black hole, your clock will tick slower, but you should still be able to escape so long as you don't cross the event horizon. This was what Sam Byron from Melbourne University said for his article for astronomy. What about the past? This is where things get truly interesting. A black hole bends time so much that it can wrap back on itself. Imagine taking a sheet of paper and joining the two ends to form a loop. That's what a black hole seems to do to time. This creates a natural time machine. If you could somehow get into the loop, which physicists call a closed time-like curve, you would find yourself on a trajectory through space that starts in the future and ends in the past. Inside of the loop, you would also find that cause and effect gets hard to untangle. Things that are in the past cause things to happen in the future, which in turn cause things to happen in the past. This sounds wonderful, right? With a black hole under your hand, you may be able to have an exotic trip to real Jurassic Park. Just do not get eaten, please. Or maybe any exciting time period you might want to see. I would personally love to have a talk with a few philosophers. Wait, Here is a catch. I mean, two of them. The first one is that you are going to undergo a spaghettification. Yes, I kid you not. It is indeed a real scientific term. Spaghettification means that upon entering of the black hole, you would be stretched into a noodle-like shape. Good job explaining this to your boss in the next morning. Letter goes like this. When you enter a black hole, you will be only able to travel to the past of that exact black hole, which means that you would probably have to cancel your plans on the visit of the world of dinosaurs if the black hole is not old enough to get you there. So, here we have an explanation on how it is possible to travel through the black holes in the block time theory and why only through the black holes. But let's portray this into our box. So now, in the box, where we have a separate place for the time or events it consists of, we now have a way to travel to the past. But back on the theory itself. The theory is to describe the things as they are existing on the timeline can be actually divided into two possible categories: eternalism and presentism. Why am I bringing this to the end of this topic? After we are familiar with the main theme, it is always good to get something to the comparison. So, according to the Stanford Encyclopedia of Philosophy, presentism is based on the thought that only present object exists. More precisely, presentism is the view that necessarily it is always true that only present objects exist. Even more precisely, no objects exist in time without being present. Abstract objects might exist outside of the time. Note that some writers have used the name differently, and unless otherwise indicated, what is meant here by present is temporarily present as opposed to partially present. In this theory, things that have ceased to exist in the past or are yet to be born in the future just simply don't exist. This opposes the block time theory, as according to that, everything exists on the same line. When it comes to the eternalism, that's what we can call the main branch to the issue concerning the block time theory. According to that theory, everything exists, nevertheless, if it was in the past nor in the future. The location doesn't matter at all. What a ride! At first, we started with the block time theory itself, using the Little Princess box as the perfect example to the cosmic blues we have been through. Why was it the box in the first place? It was all because, as the Little Prince has said himself, there can be whatever we want to have there. The sheep I want to have there is secretly a supernova about to explode, or even it is the time itself. When we have went through the relation of the past, future, present, and have concluded that these don't have any valuable meaning in the block time theory, as they are, let's say, the same thing, because the past was once the present and my now is different from yours. All it takes is me to not having this watch set on the correct time as, like, for example, you have. I mean, you might be able to say that you technically aren't late because you have come right on time and hence the time is relative. You would technically be correct, but I don't recommend to use this as an excuse to your boss for why are you late. We also have explained to each other why it is necessary for this theory to insist that time is a fourth dimension and explained how does it work like. We have also been talking about black holes and why it is possible to travel back into the past. What I have said a word or two about the presentism and eternalism, from which the first one is highly soliptic. Just to say that my hamster I had as a child doesn't exist because it is dead now, this just, I would say, a little off to me. If I may bring my personal insight inside of the lecture I have prepared for you all who are listening to me, I will gladly do so right now. As it goes, talking in the spirit of science, we know that the time is a thing that helps us to understand a lot of phenomena happening in the world, as it is one of the constants. But let's check this up from the other way around. Relativeness of the time is making me to question whether the time we are experiencing as living entities isn't, at some point, an illusion. In the history of philosophy, we might be familiar with the conceptions of cyclic time. Let's talk about, for example, Heraclitus, the Greek philosopher who believed that essence that has created the world, which is actually arche, is the fire. Besides the theory of the arche being fire, he was also the first to state that the history and the time is a cycle. Later, it was Nietzsche who has adapted this theory on his own likings and used it in his own philosophical understandings of the time. Then, we have, for example, Schopenhauer, who considers the time to be very much a thing that has a place in our minds. If we think about the cyclic time, which in short means that history does in fact repeat itself, we can't count on nothing that we can call future. Here we have changed the line in the box in the circle. Technically, no, we have no past, no future, but this doesn't end up here. The future of an object Y is dependable on the past of the object X. This makes the cyclic time to be even more meaningful. But guess what? We do have a problem. Unlike of the presentism, if we look at some simple science, more precisely at the fact that it takes some time for us to see the light, that it takes a little bit to feel, and also it takes a little to be able to express something or to move your hand, because the signals to move the limb has to come from the brain, nothing at all is present. But let's return to Schopenhauer. Time, although together with space is a causality, what we see and feel is a sensation created by our brains, and we know that to create the image we see, the light has to undergo a certain process in our brain, which we may feel is immediate, but it doesn't have to be. Therefore, we are living in the past. Bringing this timeline with no present or past into the cycle, it makes more sense to say that the history repeats itself. This might also come into very extreme connection to the block of time theory. If the past of X is a direct cause of the future of Y, the history does repeat itself. That means that somewhere in the possible world where Y and X exist, where Y1 and X1 who had the same qualities as X and Y. This might also support saying that there is nothing new to be created ever in the time. But right here, I would like to end this podcast. Thank you all for watching this with me. If you like this, please leave a like and subscribe to the channel for more interesting content. Take care of yourself and remember to drink an appropriate amount of water. Bye!